Amazon Athena. So AWS Athena is a service using which we can query data from S3. Data can be of format CSV, JSON, Parquet, and so on. Using this, we can quickly and instantly query from the S3 location. It is super powerful, and let us have a quick demo of Athena. So when you first navigate to Athena, the landing page, you will find this particular page, and then you have this get started dialog. You have options such as TrinoSQL and PySpark. So for this use case, we'll be going ahead with TrinoSQL. Since it is really straightforward, you can use SQL like queries to run the queries and fetch data, filter data from the S3 location. So click on launch query editor. So first you will be presented with this particular page, the database console, very similar to Workbench or any other DB console, wherein you can type SQL queries, SQL like queries. So this is one example. Let us remove this. So this will be the empty console, and then on the left you will find data source, catalog, and database. You can switch between different databases, and per database you will have tables. So that is one thing. And then work group on the top. So this is very important because if you look at the architecture, right, so an Athena has a work group. Using work group, you can actually it is like a bucket that has different applications or different tables related to a particular application. So segregates all of this into one, which is very useful when you want cost optimizations, cost related information, and so on. So you have to create a work group for your application, and then uh, so that is one. So let us go to work group. So for this use case, we'll be creating one work group. So on the left hamburger symbol, click on that. You will find work groups under administration. Click on work groups, create work group, give it a name. For our purpose, it will be demo work group. You have to select the analytics engine. Like I said earlier, it will be SQL. You can also go ahead with Spark, wherein you can write PySpark or Spark related kind of scripts that will be run as a Databricks application. So you can do that. But for now, we'll go ahead with SQL, and then down you can provide authentication, and then you can keep everything as defaults except for query result configuration. This is really important. Why, you will come to know later, but for now let us create an S3 bucket. The bucket is already created. If I go back to S3, there is one bucket for this demo purpose, and inside that we'll create two folders: input and one more folder called output. Okay, let me place this to the left. Yeah, create folder. So you have two folders, one is input and the other one is output. So we will use output folder in that particular form selection. So here you can provide the location to the output folder. Click on browse S3. Inside this bucket, here is the folder. Just select this, don't go inside, select that folder and click on choose. So that will be the output location. So if you look at the description, it is just enter an S3 prefix in the current region where the queried result will be saved as an object. So whenever you run a query, the queried result meaning so every query will have a filtered data, right? Will have filtered data. That filtered data will be stored in this particular location. So that is what it means. So everything else you can keep as it is, the defaults. Click on create work group, and your work group is created with these details. You can explore. Let us go back to query editor, select that particular work group, which is this switch. You have the work group selected, and now if you see, now there are two parts to this, right? So you have the work group ready. Let us go back to the diagram. You have the work group ready. You need this, a database and tables. and a table will be communicating with an S3 location, S3 bucket that has the data that you want to filter, process, or something. It is, and remember, Athena is a SQL editor kind of thing. You will only be able to read and you will not be able to write something back to the location. So remember that. So one is we need a database, two we need a table, three we need location which contains that particular S3 file. So let us start with a very basic thing, which is this input location. So here it is, S3 bucket, and set that input folder. So for this use case, I have actually used this repo to download one file, one sample CSV file that we will be using for demo purposes, and that file is this. Yeah, so the file is this. It has basic information about the customer, index, customer ID, the name, company, and so on. These are the columns, and this is the data. It is a big file, around 10,000, like the title says, 10,000 rows. Let us upload this in the input location. Here it is, input location, add files, customers, upload. Yeah, so your location with the file is ready. Next you will have to create a table and a database. For that you can select database and then create. You have this option, create table. So what this does is it gives you a query that you can modify. For example, here new table name, you can give name of your table, and then you can manually enter the name of the columns and so on, and the location of the file that we just created, the folder which contains the CSV file, and so on. You can use this, or you can have a more interactive way. You can click on create again, and then here create a table from data source. Our data source would be S3 bucket, right? So click on S3 bucket, give the table a name, something like customer info, give a description, optional, and all that, and then you can create it. You can configure a database. You can choose an existing one if your application already has some database configured in Glue. By the way, databases are created in AWS Glue. If it is already present, and if you are creating a new table within that particular database, you can use an existing database. But for our use case, we'll be creating a new one. Create a database, and then name of the database would be something like customer application, and the location, obviously, right? If you look at the diagram, the table will be mapped to one file, and the file we will be specifying here, location. Click on browse S3 Athena and the location, input. So you don't have to provide the name of the file, just the folder that houses that file is enough. So up to input is enough. And then let's scroll down. Data format, we know that our data is of type CSV, so select CSV here, and appropriate properties are populated. Field.delimiter, that is each column will be separated by a comma, so that is auto populated. You can customize this. You can provide something like colon or something else if your file is of such pattern. So for now, comma is enough, and the column details, you just have to populate these values. Let us go back to our table. First one is ID, index, customer ID, and so on. Index of type integer, first name, fname, string, lname, string, and then you have company, city, country, and so on. Company, city, country, phone 1, phone 2, that is the alternate phone, email, and so on. Phone num, alternate phone num, email, subscription date, email, So date, which is of tag date, and then website string. The rest of the columns also, let's give the data type as string. Okay, almost done. Yeah, so these are the columns that are present in our file, and also as you populate, you will see that a query is being generated, right? So as you, like for example, when you provided the name of the table and also delimiter and so on, a query is generated. As you can see, name of the table, there is the name of the DB, and these are the column names and appropriate data types of each column, and then a location. Sorry, that is my cat. Location. So location would be the place where your file is present, and then the type, table properties. So you can actually copy this and keep it somewhere so that you can reuse this whenever you want. For example, if you want to drop this particular table, that is just the cat. So you want to see, she is here. There she is. Yeah. Okay. So you can copy this particular query, reuse this whenever you want. You can drop that table, and readily you can use this. You can modify the column names, and as it is you can use. And one important property that I missed is this. If you click on table properties, skip header line count, you can, so if you go back to the table, right, depending on the need, for example, this table has a header, so you would want to skip this particular header. So click on so provide a value of 1, so that means the first column, the first row would be skipped. So that is the purpose of this particular head property. And then click on create table. That's it, and the table is created. Yeah, table is created. You can quickly explore the table, preview table, click on the name of the table and then the 3 dots, preview table. So that would give you like what the table contains, like the actual data that is being fetched from the S3 location, and you can see it is super fast. You can also do something like limit 1000 the rows are returned. You can see only 100 rows are written. That is because, let us go back to the first concept, right? If when you were creating the table, you also specified output location. So by default, where in the console, in the AWS console, results are restricted to 100 entries, 100 rows are returned. But if you want all of the rows, like the filtered rows, all the data, whenever you run a query, that query result will be stored in the output location. That is, go to S3 and then inside output, the latest file is this, and when you download this and open it, yeah, you will see that this will contain 1000 entries. So whenever you run a query, the query is actually bound with an execution ID. Each query run has an execution ID. That execution ID will be used to create the output file. Output file will be of the same format, so execution ID .csv, and that file will contain all of the rows that you need, that you just filtered. So you can read directly from the S3 location, output location. So that is how usually like my application, the backend one that I implemented, uses the same approach. So what I do is something like this. So we have a backend application that communicates with Athena. So intermediate would be something like JDBC template. So this will be used to communicate with Athena. We'll provide some of the connection URL and so on, and that reads obviously from S3 location like I showed you earlier. and returns data. But if the data is really big, it's huge, it's not ideal to kind of retrieve everything and construct objects and so on. So what alternative we have is, so once we trigger that query, we can actually get that execution ID, and using that execution ID we can check whether the query has completed its execution. So once that is done, we can directly fetch from S3 output location the file execution id.csv, which contains all of the output. Directly we can download from the S3 location. So that is how we can actually implement. And this use case is different. So here you have an backend application. We use JDBC template to communicate with Athena, which reads from S3. The data will be refreshed, say daily or weekly or something, that we can configure, and we can have a job to do that. We have a Jenkins job or Databricks job. That job will fetch data from different sources, transforms it and so on, and finally dumps it to the S3 input location. So every day or every week, whenever we fetch from Athena, data will be new, refreshed. So that is how this we have implemented in our application. That's it. So with using SQL like queries, you can quickly read from Athena. And Athena internally, some important points, Athena internally uses Hive to for the SQL query optimization and so on, and fetches data super fast. So if you have any suggestions, please let me know. As part 2, I'm thinking about maybe Spark, Athena with Spark, or triggering Athena using AWS CLI or so on. So yeah, thank you so much for watching.